4, right? We know how by default 10 and 40 are going to communicate. Through which LSA router 1 is going to learn these 40 subnets? Through which LSA router 1 is going to learn these 40 subnets, or router 4 is going to learn these 10 subnets? In form of which LSA?
LSA 3.
In form of LSA 3. Which
LSA
router
3.
generate LSA 3?
Area border.
R2 or
ABR.
R2 or
router?
R3.
ABR router. Which router is ABR here in my scenario?
R2 and R3.
R2 and R3.
R2 and R3 is my ABR. Similarly,
ABR.
R2 and R3 can be ESBR also, like if here I am running OSPF, here if I am running any other routing protocol, EIGRP, BGP, in that case router 2 and router 3 will become ESBR. First of all, tell me how router 1 will get to know that router 2 and router 3 is ABR router. How router 1 can understand that R2 and R3 are my ABR, area border router.
Because interfaces are present in different areas.
So router number 2 knows I am the ABR, but how router 1 will understand that router 2 is ABR or router 3 is ABR? Through LSA 1. In
LSA 1 will be it on.
In LSA 1, ABR router is going to turn on B bit, right? So when router 1 will receive B bit on LSA 1, it will understand that this router LSA is coming from ABR router. And router 1 will calculate cost to reach ABR. Now for inter-area prefixes, whatever prefixes ABR router is going to advertise, how R1 will calculate cost for that? Let's say this 40 subnet, router 4 has advertised it to router 2 in form of LSA 1, and now router 2 is going to advertise to R1 in form of LSA 3. In form of LSA 3, right, which is ABR. And let's say cost to reach ABR router is 1 from router number 1. How it will calculate the total cost to reach in 40 subnet? How R1 will calculate cost to reach in 40 subnet? That is cost coming in LSA 3 plus cost to reach ABR router. That is going to be cost for these 40 subnets. Similarly, router number 4 is also going to calculate cost for 10 subnets, right? Who is advertising ABR? So cost to reach ABR and cost which is coming in LSA 3. Total cost will be installed in the routing table of router 4 with 10 subnets. Here you need to learn manipulation, right? How to forward traffic through ABR1 or through ABR2. How to perform load balancing. By default, even it is going to perform load balancing only, but ABR1 and ABR2. So between two ABR, how we can manipulate the path? First of all, for a moment, forget about the area. Just imagine all the routers are in same area. For a moment, all the routers are in same area, let's say in area 0 only. In that case also you have to understand manipulation. Here I am going to tell you one types of manipulation. Let me access all the router. R1, R2, R3 and R4. For the configuration, basic configuration like IP configuration, I am going to use Notepad. No, and no. Let me use Notepad for basic configuration, IP configuration or enabling OSPF on the router. Enable config T, host name R1, interface G0/0, no shutdown, and IP address 12.1.1.1 By default, OSPF network type on Ethernet link is
Broadband.
broadcast.
Broadcast.
On the broadcast network, router always elect DR and BDR, perform DR and BDR election. But here DR BDR is not required. How I will avoid that?
Point to point. Network
Yes,
type point
not
to
by
point.
configuring type 0, but by changing OSPF network type. So network type is going to be point to point here. Then another interface, let me exit, let me copy. I have not enabled OSPF on the interface, just I have changed the network type. Here another interface is G0/1, IP address is 13.1. Okay, and then some loopbacks. Interface loopback 1, IP address 10.1.1, 255.255.255.0. On the loopback interface, OSPF network type is loopback. Loopback is also one types of OSPF network type. And on the loopback network type, OSPF always advertise prefixes with /32. Here also you can change network type, because I am using loopback just for testing. Otherwise here I will have physical interface where LAN users will be connected. Loopback 1, loopback 2 and loopback 3. On loopback 2 my IP is 10.1.2.1 and on loopback 3 my IP is 10.1.3.1. Okay, so you can see I have not enabled OSPF anywhere. Let me copy commands and let me paste these commands on R1. All the commands are accepted. Let me save the configuration of R1. Let me configure R4 now. For R4 you can see here 0/0 will have what IP? 0/0 will have IP 24.1.1.4 and here 34.1.1.4, and on loopback instead of 10 say 40, 40.1.2.1 and 40.1.3.1. These are my configurations of OSPF on router number 4. Let me, oh my god, I have pasted this command on R4. Let me correct it. This is for R1, not for R4. It was just a mistake. 12.2, 12.1 and 13.1. Copy and let me paste it on R1. Okay, again for R4 24.4, 34.4, 40.1.1, 40.1.2.1, 40.1.3.1. Copy and
Host name.
host name is going to be
Okay. Yeah.
R4.
Okay.
Copy, paste it over here. All commands are accepted. Great. Write the configuration, save the configuration of R1 also, then R2. On R2 I am not going to get any loopbacks for now. Later for testing here also I will add some loopbacks. Host name R2, IP on G0/0 is 12.1.2 and IP on 0/1 is 24.1.1.2. Copy and paste it on host name R2. Great. Write it and R3. Host name R3, G0/0 will have IP 13.1.1.3 and 34.3, 34.1.1.3. Copy and paste here. We are done with the basic IP configuration on all the devices. Write it. Now for a minute I am going to enable OSPF single area here in my topology. Single area. Go to R1 and say config T router OSPF1, router OSPF1 and router ID 1.1.1.1. Exit. Router 2 router OSPF 1 router ID 2.2.2.2, router 3 router OSPF 1 router ID 3.3.3.3, and router 4 router OSPF 1 and router ID 4.4.4.4. Now from R1 I am going to enable OSPF on interface interfaces G0/0 to 1 and interface range G0/0 to 1 and loop back 1 to 3. IP OSPF 1 area 0. Go to router number 2, interface range G0/0 to 1, IP OSPF 1 area 0. Do show history. Okay. R3 interface range G0/0 to 1, IP OSPF 1 area 0. R4 interface range G0/0 to 1 and loop back 1 2 3. IP OSPF 1 area 0. So this is single area OSPF domain, right? All the interfaces of routers are in area 0, and here you can see on router number 4 we have 2 OSPF neighbor. From router number 1 we can start verifying it. So IP OSPF neighbor, here you can see we have 2 neighbors and both are in which state? Full state, and there is no DR and BDR. Done. On router number 2, so IP OSPF neighbor, good, 2 neighbor. R3, so IP OSPF neighbor, great. On R4, so IP OSPF neighbor. Now tell me, in the database of R1, if I am going to open database, so IP OSPF database, how many types of LSA will be there? How many types of LSAs will be there?
1 and 2.
1 and 2. Very good. Anything else?
Next,
4, sir.
4. Very good.
4 will 4.
There will
How
be
much
only
is-
one type of LSA, router LSA,
Yes,
right? In the
okay, router
database.
LSA.
There will be no LSA 2.
Okay. Okay, DR is not there. Sorry.
Only DR router generate LSA 2. And how many router
Only
LSA
one.
will be there? 4. Because we
4
have 4
will
4,
routers
4,
in
sir. Yes,
OSPF
sir.
domain, and we know all the routers in OSPF domain generates LSA1. LSA1 can cross the area. Actually, LSA1 is the detailed information of links, states of links. Through router LSA, only router can see the entire topology. That's why we are saying between area, OSPF is not link state routing protocol. OSPF is pure link state routing protocol within the area. So IP OSPF database. Here you can see in database we have only router LSA, right? Router LSA, and there are 4 router LSA. This is router LSA of router 1, router LSA of router 2, router 3, and router 4. Where I will find these 40 subnets? In the router LSA of router 4. Correct. If you will open this router LSA, you will find these all 40 subnets. Where I will find these 10 subnets? In the router LSA of router 1. Okay. Let me open router LSA of router 4. Router and 4.4.4. We open LSA with the help of link ID. Remember this. Here you can see this is again LSA header, and here is a stub network information 40.1.3.0, 40.1.2.0, and 40.1.1.0. Who is advertising these prefixes? Who is advertising these prefixes? Router 4, coming from router 4, because destination networks are in same area, so it will come from in form of LSA1 only. And what is the metric coming? What is the metric in LSA1 of router 4 for this subnet?
1.
Is it the metric from R1
1.
to 40? Is it the metric from R1 to 40? No. Which metric
No,
it
no.
is? It is the metric from advertiser router to destination.
Look back. Yeah.
To the destination. Advertiser router who is advertising this LSA to the destination. Cost is 1. Got it, guys? Can anyone tell me how router 1 is going to calculate total cost for this subnet? Let me show you what is the total cost. So IP route OSPF. Here you can see total cost is 3. Can anyone tell me how it can calculate the cost for this 40 subnet? Praful, for that router have to design topology, right? First, so IP OSPF database. Sorry. So IP OSPF database. There are 4 routers, right? Router 1 is going to open their own database first, their own router LSA. It will get to know about the neighbor router, router 2 and router 3. It will calculate the cost for neighbor. Then it will know that router 3 and router 4 are connected with another router, that is router 4, and destination networks are connected with router 4 only. So when it will see the entire topology, then it can calculate the cost like this. So IP OSPF database and router LSA 1.1.1. Okay, who is my neighbor? See, point to point neighbor. These are stub networks, and here is a point to point neighbor. Router 2. What is the cost to reach router 2? 1. Great. Then, so IP OSPF database 2.2.2. Who is the neighbor of 2.2.2? Link another router 4.4.4. What is the cost from router 2 to destination? 1. One is the cost from me to router 2 and one is the cost from router 2 to router 4. That means what is the cost from router 1 to router 4? 2. And what cost is coming in LSA 1? 1. So total metric is 3. This is how router 1 is calculating cost. Here, right now my router is performing load balancing. So IP route OSPF for all 40 subnets, correct? I don't want that. Let's suppose upper path is my primary path, best path. Here we have more bandwidth, here we have less bandwidth. By default, bandwidth on all gig link is same. That's why router 1 is calculating same cost. If I am going to change the metric of any link, let's say metric of this link. If I will change the metric of this link, router will calculate different metric from this path and this path. Right now on the gig link, router is calculating metric 1 only. Why? On the gig link, metric should not be 1 because on fast Ethernet link also metric is 1. Here if you want to see the actual metric for gig link, then you have to change the reference bandwidth, right? By default reference bandwidth is 100. Right? So see, one very small command which you can run on any router, like on router number 3 I can run this command. From router number 3 I can advertise maximum metric. What I can advertise? Maximum metric for all types of LSA. For now, for router LSA I can advertise maximum metric. See, router OSPF 1, and I can say max metric and then tell me the LSA, router LSA. That's it. Now R3 will advertise maximum. Now if I will take you to R1, if I will show the routing table, now you can see all these prefixes are based from R2. Now it is not performing load balancing. All the prefixes are based from R2. And when R2 will goes down, will it install alternate path? You can try interface G0/0. Before doing that, now you can check the metric once again. So IP OSPF database and router LSA of 1.1.1. If I will open the router LSA of router 1, here just look for point to point neighbor link, neighbor 2, metric 1, and what is the metric for neighbor 3.3.3? Let me show you. Here you can see for neighbor, another point to point link neighbor, metric is 1 only. Metric is 1 only here in the router LSA. So IP OSPF database 3.3.3. Here you can see metric. For 1.1.1. To reach this neighbor, what is the matrix? 65535. This is what? Because of router OSPF max matrix router LSA. In router LSA, in LSA 1, router 3 will advertise now maximum matrix from their side. Now on R1, if I am going to down this interface, primary path, interface D0/0 shut down, and so IP route OSPF. Now you can see here is the matrix. What is the matrix to reach destination? You can still reach destination with this matrix. I can still forward traffic in 40 subnet 40.1.1 source 10.1.1. Ping is still working, and we have manipulated the path as well. Earlier it was performing load balancing. Now via router number 2, it is primary path. Upper path is the primary path, lower path is the now backup
Second.
path. Right? Here, instead of running this command, another way is very simple. Say no to this first and interface D0/0 and say no shut. Now up the port. See, in EIGRP, how you were manipulating path in this kind of scenario? You had option to change the bandwidth of physical link. You can change the bandwidth of physical link. You can change the delay of physical link. But what I had told you, this is not the recommendation. You cannot change the bandwidth of your actual link because other protocols are also running. But in OSPF, you can directly define the cost value. See, like this. Here I want to perform manipulation. So IP route OSPF. Again, it is performing load balancing on this interface. On G0/1, interface G0/1, I can configure OSPF cost like this, IP OSPF cost, and let's say 10. So now 1 is the cost of this link, 1 is the cost of this link, 1 is the cost of this link, but cost of this link is, this port is 10. So now again, if you will check routing table, so IP route OSPF, you can see best path is from via router number 2. And again, if router 2 will goes down, interface D0/0 shut down, then it will install the backup path. Here you can see. And what is the matrix? 12 from this side, right? 1 is the matrix from router 3 to router 4. 1 is the matrix router 1 is advertising in router LSA, and 10 is the matrix to reach router number 3. To reach router number 3. Got it? So here I have not changed the physical bandwidth of physical link. What I did, I have configured OSPF cost. It will only manipulate OSPF path, not other traffic.
So it will be for R4 also. We're going to follow the same link, like while it will go to R1, like if it will.
For R4 is going to use this port cost and this port cost, they are receiving interface cost only. R1 is going to use this port cost and this port cost.
Okay.
Right? You know now how OSPF calculate cost.
Yeah.
Router 1, router 2, and router 3. Let's suppose bandwidth is 100 Mbps, and here I have a network X network, right? So first router number 1 is going to calculate cost for this link. Cost is, let's say, 100 Mbps here also. So cost is 1, right? Router 2 will calculate, all the routers are going to calculate cost on their interface 1, 1, 1, and 1. You can change this value with the help of IP OSPF cost command. Now when router 1 will advertise this subnet X subnet to their neighbor router number 2, router 2 is going to use the cost of this interface plus cost of this interface, correct? Router 2 is not going to use cost of this link. Am I right? Receiving interface cost will be used similar like EIGRP. In EIGRP also what was happening? Router 1 was advertising X subnet with K values, and router 2 was comparing K values with their receiving interface. right? This interface properties, link properties doesn't matter here, right? So same thing is happening here. R3 will use this link cost, this link cost, and this link cost, these 3 port cost. And if R4 is advertising any prefix, let's say Y, so R1 is going to use this port cost, this port cost, and this port cost, whatever cost is configured there, right? If you have not apply the IP OSPF cost command, then it will calculate by using formula reference bandwidth upon bandwidth of link. Give me 1 minute, guys. So manipulation within the area, easy, right? Based on my requirement, I can configure IP OSPF cost. Now here, this is my scenario, inter area domain. So understand how we will perform manipulation over here on the ABR for LSA 3, not for LSA 1, for LSA 3. For LSA 3, see, first of all, I have to change my configuration. On router number 2, config T and interface G0/1. No IP OSPF area, OSPF1 area 0. I have removed this interface from OSPF area 0. And now I am going to add this interface in OSPF area 1. IP OSPF 1 area 1. On R3 also, interface G0/1 IP OSPF 1 area 1. And on R4, all interfaces is going to be in area 1. Interface range G0/0 to 1 and loopback 1 to loopback 3 IP OSPF area 1. IP OSPF 1 area 1. Now this is my inter area scenario. Now if I will check database of router number 1, how many types of LSA will be there?
Three.
3 types of LSA.
Two.
2
Two.
types of
LSA 1 and 3. LSA 1
LSA
and 3.
1 and LSA 3. Now let me take you to R1 and show IP OSPF database. Here you can see we have some router LSA and some summary LSA. How many summary LSAs are there? That depends on number of prefixes in area 1, right? Both the ABR, router 3 and router 4, both the ABR is going to generate what? LSA 3. Here you can see I am only receiving this 40 submit from 3.3.3. So IP OSPF neighbor. We have single neighbor, so IP interface brief. Interface is down. Interface G0/0 say no shutdown. Now R2 will also advertise LSA 3. Neighborship is up. So IP OSPF neighbor, so IP OSPF database. Now you can see the database of R1. How many types of LSAs are there? There are 2 types of LSAs, router LSA and summary LSA, LSA 3, LSA 1 and LSA 3. These are old entry, okay? Soon it is going to flush this, because now in area 0 I have 2 routers only, so there will be 2 router LSA. Clear IP OSPF process. Say yes once. And now check OSPF database. Hmm.
Correct only.
Hmm.
It's correct only, right? Four routers. Oh, but it is in different ACs.
We have 4 routers in area 0. We have 2
Mhm.
routers in area 0.
Two routers. Two
So
routers.
there should be 2 router LSA na? There
Yes.
will be 2 router LSA. 2 routers LSA are only there. These are old entry 3.3. Sorry, correct. This is old entry 4.4.4. Now 4.4.4 is not in area 0. Let me take you to R4 once and show IP OSPF interface brief. Is there any interface in area 0? No. So IP
No.
OSPF database in the router LSA. Here, see, we don't have router LSA of R1.
One.
Similarly, on router number 1, I will not have router LSA of R4. We have 3 routers in area 0 and as well as in area 1. So here you can see the LSA is, it will remove it, okay? Because of simulation, it is not removing after clearing the process as well. No problem. Here is my concern. See, 40.1.1.0, 2.2.2 is also advertising, and 3.3.3 is also advertising, right? Let me open this router LSA and summary and 40.1.1.0. Let me maximize it. You can see who is advertising this summary LSA. 2.2.2. 2.2.2 is advertising with matrix 2. And here is a 3.3.3. 3.3.3 is also advertising with matrix 2. That's why router is performing. So IP route OSPF. That's why router should perform what? Router should perform load balancing. But is load balancing happening? If there is single path in routing table, means router is not performing
Load balancing.
load balancing. Question is why? Matrix 3, I think, do so IP OSPF interface brief. Here somewhere I have changed the cost value on interface D0/1 IP OSPF cost 10 command is running. IP OSPF 10 command is running. No IP OSPF cost 10. Now you will see the load balancing here. Just a minute. Okay. There are 2 paths. If you will trace out, you will discover both the path. Here again, what I want, my ABR1 should forward all the traffic. It should be primary router ABR1. ABR1 should be my primary router and ABR2 should be my backup router, or ISP. If these are ISP, then ISP1 should be my primary router, ISP2 should be my backup router. The very easiest step is on router number 3, run maximum matrix command, router OSPF process 1 and max matrix for router LSA as well as summary LSA. Enter. Now on router number 1, so IP route OSPF. Just wait, soon it is going to synchronize. Now best path is via router number 2, and if I will set router number 2 interface G0/0 shutdown, then again so IP route OSPF. Again, you will see best path is from router number 3, and you can see the metric. Okay, so when I am running max metric command, router advertise maximum metric, right? And the neighbor router will not prefer that path if you don't want load balancing here. Another way is by manipulating the cost of this link. But if you will manipulate the cost of this link, can anyone tell me what is the issue if I will manipulate the cost of this link? Instead of running max metric command, if I will increase the cost on this link, then also it will prefer R2 to reach in 40 subnet, and when R2 will goes down, it will install lower path. But if R2 has some another neighbor, let's say, or R2 and R3 is connected with one another router in area 0, or R5. R5 is also one router in my OSPF area 0. So here also you have to manipulate the path like this. Here also you have to increase the cost. Or whatever router number 1 is going to learn on this interface, and it is going to advertise to their neighbor, it will be using cost number 10, the configured cost over here. So that's why generally we will not change the cost on this interface. Instead of doing that, for active and standby scenario, for primary and backup scenario, I will run max metric command here. And you can run max metric command for router LSA, for summary LSA, as well as for external LSA. Means we can control router LSA, summary LSA, and external LSA, LSA5, LSA1, LSA3, and LSA5. Only these 3 LSAs are used to exchange the prefixes, correct? Control plane information, LSA1, LSA3, and LSA5. Only these LSAs advertise prefixes in OSPF domain. So here, instead of running area 1, if I am running EIGRP, then your command is going to be what? Router OSPF1 and max metric router LSA, summary LSA, and then external LSA. For all type 3 LSAs, 3 types of LSAs, LSA1, LSA3, and LSA5. Router 3 will be advertising more metric than router number 2, and router 1 will be preferring upper path to reach in 40 subnet, or to reach in any subnet in area 0 from area, sorry, to reach in area 1 from area 0. There is one more command, like when you will learn the BGP, you will understand max metric and router LSA on a startup, wait for BGP. Okay, wait for BGP external LSA. Then I will talk about this command later. Okay, for now, through max command we can manipulate the path on ABR, ASBR, or we can manipulate the path within the area when we have multiple paths. From any router I can advertise configure max command. Now here we have one more types of LSA which we need to learn. Let me cover that first, and again I will come on path manipulation. But to understand LSA 7, NSS LSA, first you have to understand types of network. Network types in OSPF. Let me tell you. Anyone have idea how many types of networks we have? Network type? Or let me talk about area first. Types of area in OSPF. Anyone have idea? Yesterday I had told you about 2 area. Backbone area and
Regular area.
regular area.
Regular area.
backbone area and regular area. Now one more thing before area. Tell me, can two regular area communicate? Let's suppose I have this topology R1, R2, R3. Okay. On R1 I have one LAN subnet 10.1.1.0. On R3 I have one LAN 30.1.1.0. R1, R2 and R3. Here LAN is 10.1.1.0/24. Here my LAN subnet is 30.1.1.0/24. And this is my area 1 and this is my area 2. Can 10 and 20, 30 communicate here?
No.
Why?
No. You have to have an area 0. You have to have an interfacing backbone
What is the issue
area.
here?
ABR router is not there.
So if ABR router is not there, then who will generate? LSA3,
LSA will not be
LSA3.
generated.
right? Router number 2 is here, internal router. It will not generate any LSA3.
LSA
So
3.
router 1 will not learn 30 submit. Router 3 will not learn 10 submit, and they cannot
10%.
communicate. At least you can create one loopback interface here and you can put that in area 0. Interface loopback 1, IP OSPF 1, area 0. Now there is one interface in area 0. This router will become ABR and it will start generating
LSA 3.
LSA3. That's why we are saying backbone area must be there between two regular area. Otherwise, you will not have ABR. And if there is no ABR, who will generate LSA3? Then no one is going to generate LSA3. Only ABR router generates LSA3. Now understand types of area. Whatever area types we have discussed in last class, that is a standard area. That is a standard. There are two types of standard area: backbone area and regular area. Types of area in OSPF. Number 1 is standard area. Backbone and regular, both are standard area. You know why we come up with area concept in OSPF? We come up with area concept in OSPF to filter the database size. See here I have only 4 routers and 3 prefixes in area 1 and 3 prefixes in area 0. If I will show the database of R1, so IP OSPF database, here you can see the size of database, right? If we have lots of prefixes within the area, then the size of database is going to be large. If there are lots of router LSA carry detailed information of links and router, right? Router LSA is lengthy. And for inter-area prefixes, we have LSA3, that is again summary information of prefixes. But in the database, we have lots of LSAs. So we come up with area concept to reduce the database size. To reduce the database size. Later when we'll have the complex lab, you will see the size of database on any router. It is going to be large. And in the database, if you have lots of router LSA, that means database size is going to be lengthy. And whenever any change will occur in router LSA, all the routers are going to perform SPF algorithm. It will perform recalculation. It will recalculate the best path. Done. Here in a standard area, see all the area is by default a standard area. First of all, whatever area we have, that is by default a standard area. By default, all areas are standard area. Like here in this topology, area 0 is a standard area, area 1 is a standard area, and in a standard area all the LSAs are allowed. In a standard area all types of LSAs are allowed from LSA 1 to LSA 5. Any LSA can enter in a standard area and router will have that in their database. Route second type of area, and by default all the area is a standard area. That's why we can see all the LSA. In last class we had seen LSA 1, 2, 3, 4, 5, all types of LSAs. Every router generate router LSA in OSPF domain, but router LSA cannot cross the area. DR router generate LSA to network LSA to share the attached router information in multi-access segment. Summary LSA LSA 3. ABR router generate summary LSA to share inter-area prefix. ABR router only generate LSA 4 to share ESBR router information, and ESBR router generate LSA 5 external LSA to share external prefixes in OSPF domain. This is what we had discussed. Now second type of area is called a stub area. You know, this is again a special type of area. A stub area is going to filter some LSAs, and I can configure any area as a stub area except area 0. Area 0 should not be a stub. Let's suppose in area 2 I don't want to see any LSA 4 or any LSA 3. I can configure area 2 as stub. I can configure area 2 as stub. A stub area is used to actually filter. It is used to filter type 4 and type 5 LSA. Right? Type 4 and type 5 LSAs are not allowed in stub area. In our last topology, there was a regular area. Let's suppose here only router number 3 is connected with another router, and here we are running EIGRP routing protocol. Router number 4, and this router is learning some prefixes through EIGRP routing protocol. So R4 will become my ASBR. R4 will become ASBR router. It will on E bit. Router 3 can understand, router 2 can understand that router 4 is ASBR, and router 2 will tell to router number 1 who is ASBR in form of LSA 4, and then router 4 will advertise all external prefixes, EIGRP prefixes in OSPF domain through type 5 LSA, external LSA. If I have configured area 2 as a stub area, then LSA 5 is not allowed. Then LSA 5 is not allowed. That is issue. Now how area 2 will learn external prefixes Praful? Or let's say if not area 2, if area 1 is my stub area, let's suppose here I want to filter the database. I have configured area 1 as stub, and this is a standard area only. By default all area is a standard area. So router 4 will generate LSA 5 to advertise all EIGRP route into OSPF. Router 3 will forward that router LSA 5 to router number 2, but router 2 cannot forward it to in area 1 because area 1 is stub area. Okay, so can area 1 learn EIGRP route? No. Then how it can will forward the traffic? For forwarding traffic, your ABR router is going to generate one default route in stub area. It will generate one default route in form of LSA 3. Default route. ABR router will generate a default route in form of LSA 3 in stub area, but R2 should be ABR router. If R2 is not ABR, then we know area 1 and area 2 cannot communicate. So I'm assuming some interfaces are in area 0 also. Area 0 here. So this router is. This is one scenario which we need to perform lab and test. Stub area. For stub area. How communication will happen? For that I am going to use this lab. I already have lab. Let me show you here. 192.168.1.201 admin and if sorry OSPF area concept. See, are you guys able to see my screen? Here you can see,
Yes,
let's
sir.
suppose area 1. This area is my stub area. So if area 1 is a stub area, then router number 6 is not going to learn these 90 subnets or these 180 subnets. Okay, but Praful, area 1 can still reach to EIGRP 100 domain because ABR router will generate default route. But what about 80 subnet? How it will reach in 80 subnet? So remember, ESBR router is not allowed in stub area. What I am saying, ESBR router is not allowed. Why? Because here you can see the issue. What is the issue? If there is ESBR router connected, ABR router should be connected with in your stub area so that ABR router can generate default route. Right? If you have ESBR router connected in stub area, that is design issue, right? You have not designed OSPF network properly. Okay, so what we can say here now, we can not make area 0 to stub area. Can anyone tell me why? Why I cannot configure backbone area to stub area? If you filter any route in area 0, it will be filtered from all other area as well, from area 1, area 2, because ABR routers are only going to advertise, like let's say this 90 subnet. Router 4 will advertise this 90 subnet in form of LSA 5 in area 0, and if I will filter 90 subnet from area 0, then you will not find 90 subnet anywhere. Backbone area is connected with all the regular area. You are actually not going to apply any filtering in backbone area. Your backbone area will be a standard area where all the LSAs are allowed. And that's why you will learn area design. How we should design the network. Like let's suppose you in your company, in XYZ company, there are lots of branches and one DC. So maybe your DC will be in area 0 and all the branches is going to be in different area. What is the benefit? Why I don't have all branches and DC in single area? The full database size. Database size, right? There will be lots of router LSA if all the branches are in same area. So here you can see branch 1 is in area 1, branch 2 is in area 2, branch 3 is in area 4. So within the branch they will have full visibility. Within the branch they can design full topology, they can view the entire topology, but between the branches they will only have route exchange through backbone area only. All the areas will be connected with backbone area. It is like this. This is going to be your design. Area 1, 2, 3 and area 0. All other area are connected with area 0. So here maybe in area 1 you want to filter LSA 5 or an LSA 4, or in an area you can do that. Other thing is we cannot configure a stub area where virtual link exists. Later you are going to learn the virtual link as well. Virtual link is nothing but a feature used to extend area 0. Used to extend area 0, like in my topology. Here you can see, here we have area 2 and here we have area 5. Area 2 and area 5. I don't have backbone area in between area 2 and area 5. So here is area 0, router 5 is connected with area 0. I can extend this area 0 till router number 12. Means between router 5 and router 6, I can create a virtual link and I will put that virtual link in area 0. So that router 12 will be connected with area 0 virtually. Right? So again, in that case, this router is connected with area 0 backbone area through virtual link. So that's why we are saying stub router, sorry, you cannot configure a stub area where virtual link exists. We cannot configure, even area 0 will not allow you to configure a stub area. We cannot configure a stub area where virtual link exist. And the last thing is ESBR router is not allowed in stub area. Allowed. Okay. Now see, stub area only filter LSA 4 and LSA 5. If you want to filter LSA 3, 4 and 5, then you can configure totally stub area as well. Rest all the things are same. Stub and totally stub both are same, but stub area is going to filter only LSA 4, 5, but totally stub area can filter LSA 3, totally stub area. Totally stub area can filter LSA 3, LSA 4 and LSA 5. Only you will have LSA 1 and LSA. Only you will have LSA 1 and LSA 2. Again, in totally stub area also, we don't have like ESBR router should not be there, right? You cannot configure backbone area to totally stub area. So actually stub and totally both are same, right? One is filtering LSA 4, 5, one is filtering 3 LSA 3, 4 and 5. Configuration is going to be very easy. Router OSPF 1 area 1, and here I can say under OSPF I can say area 1 stub, or you can say totally stub. This command will enable stub. For neighborship we have not discussed this, but I have told you about flag, right? There are some flags. So when you will configure a stub area, router is going to turn on a stub flag, and this flag bit must match to have neighborship. Like in area 2 you can see we have 3 routers, router 2, router 3 and router 4. So if I have configured stub area on router number 2 but I have not configured stub area on router number 3, then neighborship will goes down here between router 2 and router 3. Stub bit must match. Now there is one issue. Praful, how to filter LSA 4 and LSA 5 in area 1 where ESBR router is connected? For that you have one another type of area: standard area, stub area, totally stub area, and fourth type of area is called
Not so stub.
not so stubby area. NSSA area. Again, NSSA area filter LSA 4 and LSA 5, but ESBR router is, put yourself on mute, brother, getting noise. ESBR router is allowed. ESBR is, so here I can configure area 1 as NSS area. I cannot configure stub, not configure totally stub, but I can configure NSSA. But Praful, in NSSA area, LSA 4 and 5 is filtered. Then how ASBR router is going to generate LSA 4? No. In NSSA area, ASBR router is going to generate LSA 7 to advertise external prefixes. ASBR will generate LSA 7 to share external prefixes in OSPF NSSA area. LSA 7 is for NSSA area only. Configuration is going to be again same router OSPF 1, area 3, NSSA. And like stub and totally stub, the last type of area is totally NSSA area, used to filter LSA 3, LSA 4 and LSA and LSA 5. When you will implement these areas, there are some small concept which you need to understand, like which router is going to, sometime you will see translation, right? Some router is going to translate LSA 7 into LSA 5, or some default route information, right, feature to make communication or to advertise default route in any stub or NSSA area for reachability. Now in NSSA area, here let's suppose my area 1 is NSSA area, so router number 7 is going to advertise all 80 subnet in form of LSA 7, in form of LSA 7. But Praful, what about area 0? Area 0 is a standard area, right? Router number 7 is going to generate NSSA LSA, that is LSA 7, it will advertise to router 6, router 6 will advertise to router 2, router 3. What about a standard area? Can we have NSSA or LSA 7 in regular area also, in a standard area also? So no guys, you will not find LSA 7 in a standard area. Here what will happen again? Router number 2 and 3, your ABR router will start sending default route, but you have to run one command for that. And what about these prefixes? For these prefixes also I can advertise default route here, right? Because router 2 and router 3 are ABR router. These routers are learning 90 prefixes in form of LSA 5, right? And 80 prefixes in form of LSA 7. But router number 2 cannot send 90 prefix in form of LSA 5 in area 1, because area 1 is NSSA area. Then how router number 6 will learn this prefix, or any router in NSSA area will learn these 90 prefixes? Here again you have to understand translation of LSAs or default information originate. Okay, so remember all the areas are standard area by default, and in the standard area all the LSAs are allowed. Stub area is used to filter LSA 4 and LSA 5, and ESBR router are not allowed there. Totally stub area used to filter LSA 3, 4, 5, again ESBR router is not allowed. NSS area used to filter LSA 4, 5 again, but ESBR router is allowed. And in totally stub area again ESBR router is allowed and used to filter LSA 3, 4 and 5. Can I move? And LSA 7 is not supported in a standard area. In a standard area we cannot have LSA 7. So ABR router will convert LSA 7 into LSA 5. If you have two ABR router, here you can see router 2 and router 2 ABR. So here ABR router with higher router ID will translate LSA 7 into LSA 5 for area 0. And in the translation, again, there are some concepts which we need to understand. So I think this lab is already configured. Let me see so that I can show you something. Here I am going to log in with admin credential, admin if and area. I think the lab is already configured, means OSPF is already enabled. Let me see, just 1 minute. The previous scenario, guys, where we had 2 ABR or 2 ASBR, there some more ways are there for the manipulation. Okay, but today we have discussed what? Max command only for path manipulation. Now we have understood the area concept. One more thing is there which we need to understand, that is network type. Different types of network in OSPF. Let me turn off. What happened here? I think devices are changed. Which router it is? Okay, lab is old. I have to wipe the configuration and then we have to configure it. So no problem. Then what I will do, I will come up with configuration, right? I will configure this lab in my free time before tomorrow class, and then in class tomorrow we will discover these all things, the area concept. Today I am moving further on the theory part. Don't worry, here we'll see all types of area. Now I am going to discuss network types here. Before network type, one thing, see, if router is going to learn any prefix with the help of router LSA, then it will install with symbol O. Any prefix in form of LSA 3 will be installed with symbol OIA. Any prefix in form of LSA 5 will be installed with symbol E1 or E2. Any prefix learn in form of LSA 7 will be installed with N1 or N2. In dynamic routing protocol, what we had discussed in best path selection, OSPF has something different for best path selection. Best path selection, what we had seen, first router is going to compare AD value and then metric, longest prefix match AD and then metric. But OSPF is going to check before metric, it is going to check route type. OSPF is going to check route type before metric for best path selection. Maybe a router is learning same prefix through router LSA, also through LSA1. LSA1, it is learning 10.1.1.0/24 and metric is let's say 100. AD value is same, LSA1, and it is learning same prefix in form of LSA3 also. Let's say LSA3 10.1.1.0/24 and here metric is let's say 10. So which router 1 will prefer which path or which route? Based on metric? No. Based on network type. Here is the OSPF best path selection. You can see AD value, then route type, and then metric. So before comparing metric, OSPF is going to check types of routes, and for best path selection, it is OSPF prefer O over OIA, OIA over E1, E1 over E2, E2 over N1, and N1 over N2. This is what? This is best path selection of OSPF before metric, right? After that, if network type is same, sorry, network type, not network type. If route type is same, then OSPF is going to check what? Metric. Then it will check metric. Okay, this is again one thing here which you need to keep in mind, remember. Now, types of networks. Let's discuss the theory. We'll configure the lab one by one for all. Network type in OSPF. How many types of network we have? Number one is point to point. Point to point network type. 4 point to point link. Second type of network is broadcast. Broadcast. And third type of network is non-broadcast. Non-broadcast. Fourth type of network is point to multi point. Fifth type of network is point to multi point non-broadcast. Point to multi point non-broadcast. Sixth type of network is loopback for loopback interfaces. And last type of network, 7, is virtual link for virtual link, when virtual link exists. On virtual link, OSPF network type is going to be virtual link only. Okay, OSP loopback and virtual link is clear. It is for loopback and virtual link. These are the network type which we need to understand. See, we have different types of network for different types of networks. Different types of network, like for point to point connectivity, for point to point link, when two devices are connected point to point, then OSPF network type should be point to point only. Like between two router, OSPF network type should be point to point only. Broadcast and non-broadcast network type is going to work fine in full mesh topology. In which topology? In full mesh topology. In broadcast and non-broadcast, router perform DR and BDR election in broadcast and non-broadcast. And point to multi-point and point to multi-point non-broadcast, these two types of networks are for hub and spoke topology. When you have hub and spoke topology, what you will configure? Spoke. In hub and spoke topology, you will see broadcast and non-broadcast network type is not going to work well. Broadcast and non-broadcast will work great in case of full mesh topology. And point to point you already know, for point to point link. Now here I am going to draw a chart for you. Here I am going to mention network type. Network type. Now here is my point to point. then broadcast, then non-broadcast, then point to multi-point, then point to multi-point, non-broadcast, and that's it. Here network type. Network type. After that, you can see hello time and date time, because hello time and date time also depends on network type, date time. You can see DRBDR, because DRBDR also depends on network type. And then you can see neighborship, a static neighborship and dynamic neighborship, where we can configure static neighborship, where we can configure dynamic neighborship. Neighborship like this. P2P, point to point, broadcast, non-broadcast, point to multi-point, and point to multi-point, non-broadcast. Okay, so remember this. In point to point network type, hello time is 10 second, dead interval is 4 time of hello time, 40 second. DRBDR election happens? Required or not required?
Not required.
Not required. On point to point link, you cannot configure a static neighborship as well, not possible. Right, between two router, when my network type is point to point, we cannot configure static neighborship. That point to point link support dynamic neighborship. Here I can say yes. Right, it support dynamic neighborship, hello time 10 second, date time 40 second, and DRBDR is not required. In broadcast network type also hello time is 10 second, hold on time is 40 second, and is DRBDR required?
Yes.
Yes, DRBDR is required, and DRBDR election will happen. Static neighborship, not dynamic neighborship. Yes, right. Broadcast support dynamic neighborship, even we have seen this in the lab. On non-broadcast network type, means in non-broadcast network type, you cannot send broadcast message, even you cannot send multicast message. In non-broadcast network type, we cannot send multicast message. So their hello time is going to be 30 second, and hold on time is going to be 4 time of hello time is 120 second. DRBDR, yes, DRBDR is still required, but it doesn't support dynamic neighborship. Here you have to configure what? A static neighborship, because what I told you, it doesn't support multicast packet. We cannot send multicast packet in non-broadcast network. In case of point to multi-point, hello time is again 30 second, hold on time is 120 second. DRBDR is not required here, and DRBDR election will not happen. Static neighborship, yes, it is not supporting a static neighborship. Here dynamic neighborship is possible, routers can become neighbor dynamically. But again, in point to multi-point non-broadcast, you have to configure a static neighborship here, yes, and dynamic neighborship is not possible. And what will be the hello time here? Again 30 second, hold on time, dead time 120 second, and DRBDR not required in non-broadcast network type. This is your a small chart for OSPF network type. And let me show you some commands here. Let me open one another topology network type. Let's say this is my topology. Internet, and I have 3 sites. Let's say this is hub router. These 2 are the spoke routers. For hub and spoke, if you remember, I had configured switch port protected to create hub and spoke topology in last class. So if I am going to configure these 2 port as protected port on, this is actually switch. Okay. Now if I will access this router, I think this is switch. Let me see. Router 1, router 2, and router mm, 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 mm. See, this is my switch config T interface G0/2 interface range G0/2 range G0/2 and G0/3 switch port protected. Now in this case, these 2 ports are not connected, right? Router 2 and router 3 cannot communicate. Let's suppose here my IP address is dot 1 192.168.1.1 1.2 dot 2 and dot 3. So dot 2 and dot 3 cannot communicate, but dot 2 and dot 3 can communicate with dot 1. Let's suppose here I have enabled OSPF and my network type is
Stubby.
what should be network type for hub and spoke? Point to multi-point or point to multi-point
Multi-point.
non-broadcast. But let's suppose here I have configured network type what?
Broadcast.
Broadcast by mistake. Okay. Now, if network type is broadcast, DRBDR election will happen. Router 3 has, let's say, higher router ID. Router 3 will become your DR.
DR.
Right? Now, R1 is going to advertise there, all submit to DR router. And this is responsibility of DR to advertise it to other side. Can this DR router advertise prefixes to other spoke router?
No. Protected.
Right? Router number 2 is not going to learn even hub side route and spoke side 3 route, because spoke router is the DR router here. That is the issue. So broadcast network type will not work in this scenario. What is the issue if router 1 is the DR and network type is broadcast? Hmm?
No, still it will form a neighborship, right? It will give the routes. But it will communicate, not directly communicate. It will communicate via router 1 to router 2, router 3.
Still they
Hub
cannot
and spoke.
communicate. Spokes cannot communicate even if hub router is the
No.
DR router. Here in this topology, you can try to configure OSPF network broadcast, and then you can encounter the issues, right? all the issues. The exact solution is, you will see OSPF is working well when my network type is not broadcast, when my network type is point to multi-point or point to multi-point non-broadcast in hub and spoke topology. In point to multi-point or point to multi-point non-broadcast, here you can see, is DR and BDR election happen? Not happened, right? In point to multi-point, neighborship will be dynamic. In point to multi-point non-broadcast network type, type, neighborship is static. Dynamic neighborship is even not possible. Here I can implement OSPF and then I can show you the issues. If you have WAN circuit everywhere, the virtual circuit everywhere here between all the sites, you can configure network type broadcast or non-broadcast. But if you have only virtual circuit between hub and spoke, the network type must be configured as point to multi-point or point to multi-point non-broadcast. If I already have access to the devices, let me configure router no. Config T interface G0/0 no shutdown, IP address 192.168.1.1 255.255.255.0, and I am creating just one loopback. IP address 10.1.1 255.255.255.0. Router OSPF, let me configure OSPF later. Interface G0/0 no cert and IP address 192.168.1.2 255.255.255.0. interface loopback 1 IP address 20.1.1 255.255.255.0 R3 enable config T interface G0/0 no search IP address 192.168.1.3 255.255.0 interface loopback 1 and IP address 30.1.1 255.255.255.0. Let me enable OSPF router OSPF 1 router ID 3.3.3.3 and network, let's say 0.0.0 255.255.255.255 and area 0. I have advertised all interfaces in area 0. Router 2 router OSPF 1 router ID 2.2.2.2 and network 0.0.0 255.255.255.255 any wildcard mask and area 0. And R1 router OSPF 1 router ID 1.1 and network 0.0.0 255.255.255.255 and area 0. I have enabled OSPF on all the router. From router number 1 I am going to ping router 2 ping 192.168.1.2 and see ping is working, even 1.3 ping is working. So IP OSPF interface brief, OSPF is enabled on both the interfaces and by default network type on gig link is broadcast, right? How to change network type? Go to interface G0/0 and IP OSPF network. This is the command, but here leave network type on default, which is broadcast. So IP OSPF neighbor, you can see R1 has 2 neighbor and R1 who is the DR? R3 is the DR router. And who is BDR? R2 is your BDR router. So R1 is going to advertise their database to DR router to R3. So IP OSPF database. Here you can see there are 2 DR. That's why 2 number of LSA 2 are there. Router 2 and router 3. Let me do one thing here on router number 2 and router number 1 interface is 0/0 IP OSPF priority 0, and on router number 1 also config T interface is 0/0 IP OSPF priority 0. See on router number 2, so IP OSPF neighbor. Router 2 has neighborship with router number 1 and neighborship state is two-way. Even router number 2 cannot have neighborship with router number 3 with actual DR. Who is the DR? Router number 3 here. Router number 1 has two neighbors, so IP OSPF neighbor 2 neighbor, one with router number 3 full, and with router number 2 only two-way state. And on router number 3 also you can check, so IP OSPF neighbor, right? Because router 2 and router 3 are not able to communicate. So here if I will check you that, show you the database, so IP OSPF database, you can see we have router LSA of, this is again old entry, clear IP OSPF and so IP OSPF database here. So IP route OSPF, you can see R2 is not learning any route through OSPF. Database is old. It will take some time to, after 180 seconds it will update the LSA. LSA age time is 180 seconds. So IP OSPF database. Here you can see the database. Database of DR router R3. There is router LSA of R3. It will also have router LSA of R1. So IP OSPF neighbor. Okay, now neighborship is up. Now you can see, right? Router LSA of R1, router LSA of R2 is also there. Router LSA of R2 should not be here. Router LSA of R3 and router LSA of R2. These two LSA will be there in the database of router number 3. And in the database of router number 2, there will be only one router LSA of router 2. So IP OSPF database. This is incorrect entry. That's why it has not installed in routing table. So IP route OSPF, you can see. So spoke can not communicate. Let's do one thing, Praful. Configure hub router as DR router. Then all issue is resolved. Let me do that. Interface G0/0 IP OSPF priority 10, and on R3 I am going to configure priority 0. Interface G0/0 IP OSPF 1 priority 0. Here I have configured priority 0 so that R3 should not become DR router. Now who is DR? Hub router. R1 is the DR router. Now what is the issue? No issue. Now so IP OSPF neighbor, you can see both the spokes has full neighborship with hub router, with R1. Go to R2 and check, so IP OSPF database, sorry not database, so IP OSPF neighbor. It has neighborship with 1.1.1 and neighborship state is full. Spoke don't have any neighborship, so IP OSPF neighbor. Spoke don't have any neighborship. All the spoke router has neighborship with hub router. Now go to spoke site S1, so IP route OSPF. Now you can see in the routing table, route is there 30.1.1.0, but can I ping 30.1.1 and source 20.1.1? Is ping working? Ping is not working, right? Because see, OSPF intra area router doesn't advertise route, they advertise what? LSA, router LSA. So router 3 is going to include this 30 submit in their router LSA, then it will advertise that router LSA to R1, and R1 will advertise that router LSA to R2. So R2 will learn the exactly same router LSA generated by R3. Only DR router is helping to forward it to other spoke to propagate it. right? Router number 1 cannot change anything in the router LSA of R3. In the router LSA of R3, router 1 cannot change anything, right? So what is happening here? R2 is learning this subnet. Here you can see so IP OSPF database. In the database, here is the router LSA of R3. If you will open router LSA of R3, you will see this link, and these all prefixes are coming from 3.3.3, and the IP address to reach 3.3.3 is 192.168.1.3, which is not reachable from I2. So in hub and spoke topology, you can see broadcast network type is not working. If I will configure network type non-broadcast, let me configure that. Interface G0/0 IP OSPF network non-broadcast. On router number 2 also, let me do that. Interface G0/0 IP OSPF network non-broadcast. R3 interface G0/0 IP OSPF network, sorry, network non-broadcast. Now what is the issue? Now you don't have neighborship. Why? Now you can see we don't have neighborship because in broadcast network type we have to configure a static neighborship. Dynamic neighborship is not supported. Correct? That's why we don't have neighborship on any router. You can see on router 1, router 2, as well as on router number 3. Don't have any neighbor. So go to router 1 and configure a static neighborship. Router OSPF 1 and neighbor. Who is neighbor? 192.168.1.2. If you want to define cost, you can configure, otherwise leave it. On router number 2, router OSPF 1 and neighbor 192.168.1.1. And on R3 also, router OSPF 1 neighbor 192.168.1.1. Now we have configured a static neighborship here. So IP OSPF, this is a static neighborship. That's why you can see a state is what? Attempt. Instead of init, the attempt state. For in case of
Here we need
static.
to configure two neighbors, right? R1.
Yes, definitely.
But here configure only one, I think so, on R1.
That's why we don't have neighborship with R3. I'm going to configure it. Router OSPF 1 neighbor 192.168.1.3. Okay. So IP OSPF neighbor, right? And see here OSPF is very slow. Still state is attempt. Hello time is, hello time over here is
30 seconds.
30 seconds, right? OSPF is slow over. Now you can see we have neighborship in full mesh, but still on router number 2, if you will check database, so IP OSPF database, we have router LSA of R3, but next hop IP address is not correct. So IP route OSPF, you can see for 30 submit next hop IP 191.1.3. Still we cannot send traffic. The solution is configure network type point to multi-point or point to multi-point non-broadcast. Let me set that. Interface G0/0 IP OSPF network point to multi-point. Go to router number 2. Interface G0/0 IP OSPF network point to multi-point. On R3 also, interface G0/0 IP OSPF network point to multi-point. That's it. Now here you can see. So IP OSPF neighbor. Why we don't have neighborship? So IP OSPF 2.2 3.3.3 full state, and there is no DRBDR. Great. So IP OSPF neighbor. So IP OSPF interface brief. So IP route OSPF. Router OSPF 1, no neighbor 192.168.1.1.
Now it is point-to-point broadcast network, right?
No, this is
Point to
point to
multi-point. Broadcast.
multi-point.
Point to multi-point broadcast network.
Why it's not showing this? So IP OSPF neighbor. Okay. Here on router number 2 we we don't have neighborship. So IP OSPF interface brief. Here network type is, I think by mistaken I have configured network type here what? Point to point on router number 2. That's why. Okay, let me correct it. Interface G0/0 IP OSPF network point to multi-point, not point to point. Now here also you will have neighborship, and now you will see everything will work well. So IP OSPF neighbor done. So IP route OSPF. Now you can see 30 submit is coming with what next hop? R1 next hop. Can I ping now? Ping 30.1.1 and source 20.1.1. Yes, you can see a spoke to a spoke. Communication is happening through DC, through hub router. Now, so IP OSPF database. In the database, you can see, right, in point to multi-point, we don't have DR and BDR. DR, BDR election not happened. Correct? We don't have any DR and BDR. We have 3 number of router LSA. In the router LSA of R3, you can see 3 number of link. If we will open this router LSA of 3.3.3, this is header, advertising router, and 30.1.1.0 submit mask, metric, and neighbor 1.1.1, neighbor 1.1.1, and here you can see a router interface IP address and another stub network. It is talking about which network? 192.168.1.3. Now in the router LSA, are you able to see the change? Is there any change or not? There is change, guys. Something is different from earlier. Now if let's say this router is designing the topology, if this router is designing the topology, what it will understand that I am learning this subnet 30.1.0 from this neighbor 1.1.1, and what is the interface IP of this neighbor 1.1.1? So IP OSPF database 1.1.1. I am on router number 2 1.1.1. IP address for this neighbor is 192.168.1.1. It is going to use this as a next hop, and that's why your ping is working. Here if you want a static neighborship, you can configure point to multi-point non-broadcast. That will also work fine, or point to multi-point for dynamic neighborship. That will also work fine. And if I will remove the command here, switch port protected command, then I will have full mesh topology. And in full mesh topology, you can try to configure what? Network type point to multi-point. Again, you will see the issue. Okay, so design this network and configure, test all types of network one by one, these types of network. And here you can take a screenshot of it, or I am going to share you this print file. You can keep it somewhere, right? Until you are learning OSPF, just keep this chart, so that you can see when DR and BDR is required, when DR BDR election happens, hello time, date time, and neighborship, static neighborship and dynamic neighborship. If I am going to connect 4 routers through one switch like this, then tell me what should be my network type. What should be my network type here?
Broadcast.
100% broadcast, right? 100% my network type should be broadcast. Can I configure non-broadcast network type? Yes. Broadcast and non-broadcast both will work in this scenario. And this is very common scenario for hub side, main side, like for DC hub side, where you have multiple or in campus as well. When we have multiple routers, all the routers are connected through one centralized switch for scalability. I had given you this example earlier as well. Okay, so here network type is should be broadcast or non-broadcast. What should be network type over here?
Point to point.
Here point to point. And what should be network type in hub and spoke topology?
Point to multi-point, broadcast or non-broadcast.
Point to multi-point or point to multi-point
Multi-point broadcast.
non-broadcast.
Broadcast, yes.
Broadcast and non-broadcast, yes. When I am saying point to multi-point, it means point to multi-point broadcast. And if we have full mesh topology, like
Broadcast.
this, see now. In this topology, my OSPF network type is going to be different from this topology. Here, what should be network type?
Here it should be point to point.
Here, point to point network type. Here we should have
And
point
here
to point
broadcast.
network type between all the router and here broadcast. Right? Again, we have 4 routers only in both the scenario, but you can see the connectivity is different. Or we have router here, here
Point to multi-point.
point to multi-point or point to multi-point non-broadcast.
Non-broadcast.
Right? So OSPF network type depends on design, how I have designed and how I have connected the devices physically, right? Depends on topology. Topology is what? Physical connectivity of devices is topology. And OSPF network type also depends on topology. Tomorrow I will discuss virtual link and I will show you the lab of all types of areas like stub area, NSSA area, totally stub area and totally NSSA area. That's all for today. If anyone have any question, please ask. Otherwise, it's your turn. Perform this lab. In hub and spoke and full mesh topology, you can try to implement OSPF and you can try to implement different types of network. You can see which type of network is working well.